So in the previous video, we talked about inverse functions and what that might look like with a table or a graph. And today we're actually going to look at a function written out and find its inverse as an equation. So here are the steps. If your function is written as f of x, I would recommend changing that to a y first of all. Remember, those are the same thing, but it's just gonna make this a little less confusing. Because what you're going to do is change all the x's in your function to y's and change all the y's in your function, probably just the one, to an x. Because remember, in inverse functions, the x's and the y's are flipped. So that's why we're going to do that. Then you just need to rearrange some things so that you can solve for y, so that you have your function in like y equals format. And then that is the inverse, so we'll change y to f inverse just to be a little more explicit. So here's a few examples of that. I want to find the inverse of this function right here. It's a line. Just thinking about if I were to reflect a line, I would get another line. So the function that I get as my inverse should also be a line. So step number one is I'm going to replace f of x. Whoops. Sorry. I'm going to replace f of x. Oh my goodness. There we go. Replace it with a y. The reason we're doing that is because there's an x here and that's confusing. So my new function looks like this. So what I'm going to do to find the inverse is I'm going to change this into an x, and I'm going to change this x into a y. Again, I'm just flipping x and y. That's how you find the inverse. And so this is the inverse function. It's just things are a bit rearranged. Typically when we have functions, we want y to be by itself. So what I'm going to need to do is move some things away from the y until I get it by itself. Remember, when you're undoing things, you go backwards of the order of operations. So the adding and subtracting stuff will come first, then this multiplication we'll deal with. To get rid of plus 1, I'll subtract 1 from both sides. Some people might call this like negative 1x, but be careful, this is x minus 1. I can't combine those, it's just x minus 1. Next, I need to get rid of negative 1/3. There are a few ways you could handle this. One way is you could multiply by 3 first to get rid of that 3, and then divide by a negative 1. That's one way you could handle it. You could also multiply by the reciprocal. So to get rid of 1/3, I'll multiply by 3 over 1, or 3. And to get rid of a negative, I'll multiply by another negative, because negative times negative will leave just a y. If I'm going to multiply this side by a negative 3, I also need to multiply this side by a negative 3. If you want to put it over 1, that's fine. But be careful, I need to multiply everything that was already over here by that negative 3. So it needs to be like this in parentheses. All right, so 3 and 3 cancel, 1 and 1 cancel. Negative times negative is a positive, so I'm just left with y over here. And then you can leave this as it is or distribute the negative 3 to get negative 3x, and negative times negative is positive 3. Now I have y by itself, and so my inverse function is y equals negative 3x plus 3. If I want, I could flip that around, like y equals negative 3x plus 3. And just to be a little more explicit, I started with the function f of x, and then I found the inverse. So instead of a y, I'm going to call this f inverse, just renaming it. So let's write that out. It looks like f inverse equals negative 3x plus 3. You'll notice some similarities between the numbers, and again, this is a line like we expected. Let's try another one. This one has a cube root in it, and it's the function f of n, and we want to find its inverse. One thing that I might recommend is instead of using the variable n, let's use the variable x. You don't have to, but I think it's just easier to use x instead of n. So just replace the n's with x's. And remember also, it's easier, instead of calling this f of x, let's call that y. So y equals the cube root of x plus 3 plus 2. Now to find the inverse, remember I'm going to switch out y for an x, and I'm going to switch out this x with a y. And that is the inverse. I just need to rearrange some things so that y is by itself. All of this is protected under the radical, so that needs to happen last. What needs to go first is this plus 2. So I'll subtract 2 from both sides. X minus 2 is left over here. And on this side, we've got the cube root of y plus 3. All right, now this radical is like it's protecting the y plus 3. It needs to go away before I can deal with the stuff inside the radical. So to get rid of a cube root, I will cube this side of the equation. That cancels out the cube root. If I cube this side, I also need to cube this side, the entire thing. So now that those cancel, I just have y plus 3 left. On this side of the equation, it's tempting to cube both of those, but you can't because that minus, these are two separate terms and you would need to actually expand it out. And so we're just going to leave it as it is. Just leave it as x minus 2 cubed. That's fine. Lastly, to get y by itself, I'll subtract 3 from both sides. And now I have y by itself. It's also tempting here to do negative 2 minus 3 is negative 5, but all of this is cubed, and so that's kind of its own thing at this point. The negative 3 doesn't get to join the party. She's gonna have to stay outside here. So I'll just put minus 3 on the end. And this is my function. Y equals this stuff. Remember, it's nice to rename things. So originally I had f of n. So why don't we change this x back to an n? And instead of y, I'm just going to call it the inverse. So let's call this f inverse of n. Last example. Oh, and notice on this one, we started with something that had a cube root, and we ended with something that was cubed, because those are opposites of each other. On this last one, I'm going to find the inverse of this thing. So instead of f of x, let's call that a y. The reason I do that is just because this x gets confusing if it's in there. So because you change x to y so that you change it back to x. I know that's confusing, but so this is y equals all of this stuff. And now what I'm going to do to find the inverse is replace the y with an x and replace the x with a y. Now let's solve for y. Since all of this is in the numerator divided by 2, I need to get rid of that divided by 2 first. So I'll multiply both sides by 2. To cancel that out, I'm left with 7 plus 4y equals 2x. Next, again, I'm going backwards of the order of operations. So before I divide by 4, I'll need to subtract 7. 2x and minus 7 are not like terms, so they're going to have to stay separate. Finally, I'll get rid of the 4 by dividing by 4. on both sides so that I have y by itself. If you want, you could break this up into 2 over 4 and 7 over 4. I'm just going to leave it as it is because it doesn't simplify that much. So that is my final answer. Again, instead of a y, I'm going to rename this as f inverse because that is what we just found, the inverse of f. So f inverse is equal to this, 2x minus 7 over 4.